For 12.4, we're going to look at geometric probability. So by the end of this lesson, you should be able to calculate the geometric probability of various events. So we're going to be using outcomes like area, volume, length, and all that to come up with our probability. So here we have a problem. It says, place your bets. You're going to throw a dart with your eyes closed. Will you hit black or gray? What I want you to notice is that you have two circles. You have area 1, which I'm going to highlight in pink. And then we have area 2, which I'm going to highlight in purple. And our area 2 is also going to be what we're going to refer to as our total area. So the one thing that we want to look at is we've got two circles, and notice that we have a black ring here that is outside of the smaller circle and inside the larger circle. So to find the area of the ring, you're going to take the larger circle, which we have designated area 2, and subtract area 1. Now they're all circles, so as a reminder, to find the area of a circle, that is equal to pi r squared. And we're going to use 3.14 for pi. So the question we have here is, what is the probability you will hit the black ring? Again, probability is your success over your total possibility. So we will be successful if we hit the area of the black ring, and then we have to base that off of our total area. So again, area of the ring is area 2 minus area 1. Area 2 has a radius of 3 plus 2. So that would be 5. So we have pi times 5 squared. And we're going to subtract the area of the inner circle, which has a radius of 3. So we have pi times 3 squared. And we're going to divide that by the total area, which is the larger of the two circles. Pi times 5 squared. Working through the math, we have 25 pi minus 9 pi divided by 25 pi. Simplifying the numerator, we get 16 pi divided by 25 pi. And I can go ahead and cancel out my pi's, leaving me with 16 over 25, and that will give us 0.64. So that is the probability we would hit the black ring. Next question is, what is the probability you will hit the gray ring? Well, the gray ring is area 1, which has a radius of 3. So we have pi times 3 squared. We're going to divide it by the total area, which is the addition of both rings, which is pi times 5 squared. So we now have 9 pi over 25 pi. And again, we can cancel out our pi's, and that gives us 9 over 25, which gives us 0.36. So that is the probability that you would hit the gray ring. In this scenario, we have a rectangle with a circle and a triangle inside the rectangle. You're going to throw a dart with your eyes closed. Will you hit white or gray space? So the first thing I want to do is designate my different areas. Area 1, which is a circle. We have a diameter of 4, so our radius will be 2 inches. So this will be pi times 2 squared, which gives us 4 pi. Again, we're going to multiply by 3.14, so the area of our circle is 12.56 square inches. Okay. Then we have our triangle, which I'm going to designate as area 2. To find the area of the triangle, you're going to take the product of the base and the height, 6 times 8, and divide by 2. This gives you 48 divided by 2, so you get 24 square inches. And last, we have the rectangle. I'm going to designate that area 3. And notice that area 3 is also your total area. To find the area of a rectangle, you take base times height, so you get 200 square inches. So now we have all the information that we need. Okay? There's several different probabilities that we could calculate. One is, what is the probability when you throw your dart it's going to land in the gray area? The gray area can be found by taking area 3 and subtracting area 1 and subtracting area 2, dividing all that by the total area. So we've already calculated the different areas, so we now have 200 minus 12.56 minus 24 divided by 200. This gives us 163.44 divided by 200 gives us 0.817. Again, we're rounding to the nearest hundredth, so this would give us a probability of 0.82 of hitting the gray area. If we want to calculate the probability of throwing the dart and hitting the white area, notice that our circle and our triangle are the white areas. So we would take the sum of area 1 plus area 2 and divide it by the total area. 12.56 plus 24 divided by 200 gives us 36.56 divided by 200, 0.182. Again, we're rounding to the nearest hundredth, so this would become 0.18 would be the probability of hitting the hitting the white. Notice if we add the probability of hitting the gray to hitting the white, we get 1, which means we have covered all of the areas in this diagram. Moving on, what is the probability we would hit the circle? this would be area 1 divided by the total area, 12.56 divided by 200, which gives us 0.062, rounding to the nearest hundredth. So we get 0.06 probability of hitting the circle. And last, what is the probability that you'll hit the rectangle? Well, the rectangle is area 3 over the total area. So you have 200 divided by 200. So the probability of hitting in the rectangle itself is 1. It is a certain event that your dart would land in the rectangle. All right, in this last problem it says if you choose a random point, what is the probability it will be in the gray space? Okay, so the first thing we have, our total area is a square. And we also have two halves of a circle. Radius is 16, diameter is 16, so the radius would be 8 feet. So we are looking at, to find the gray space, we would take the area of the square, which I have highlighted purple, minus the area of the circle, which I highlighted green. Just to clarify, the total area is also the area of the square. So using the formula to find the area of the square, it is your base times your height, or your side squared, so 16 times 16, 256 square inches. The area of the circle equals pi r squared, which is 64 pi. When you multiply by 3.14, you get 200.96 square inches. So now to find the probability of hitting the gray space, you can take the area of the area of the square minus the area of the circle and divide that by the total area, which is also the same as the square. This leaves you with 55.04 divided by 256, 0.215. Again, we always round to the nearest hundredth when it comes to probability. So the probability that you would hit the gray space is 0.22.